just wanted to tell you a bit about the Science Gateways Community Institute. If you're new to this webinar series, I know I recognize many names on the list, so I know a bunch of you are not new, but so I'll go through this quickly. But essentially, the Science Gateways Community Institute is funded by the National Science Foundation to facilitate the community of gateway developers and users to help them share experiences, technologies, and practices at little to no cost. So we have both our online resources, such as this webinar, and our website, which has various kinds of digital resources and is going to be growing that collection, as well as in-person events such as a conference and other things that I'll mention shortly. So we have 5 service areas, and our first service area is the incubator, which is essentially like what you would think of as a startup incubator, but it provides guidance and expertise about the kinds of specialty knowledge that you might not have available to you if you're a developer at a university. They also offer a boot camp, which is a 1-week intensive experience for gateway developers to attend, and it's usually 2 or 3 people per project, and applications are required, and that application is up and going to be promoted shortly. So if you're on our newsletter, you'll definitely hear about it. Extended developer support is our hands-on area with helping gateways get their gateways built or a new feature being built, and you can have up to a quarter-time person working on your gateway. You can apply for that on our website as well. The Scientific Software Collaborative has created a gateway catalog, which is currently already has a number of gateways listed. If you have a gateway that's not on that, we encourage you to add it. And then in the coming months, we're going to be adding software components as well. So it would be a great way to find things that you may want to repurpose for your own use. The community engagement and exchange area is what you're engaging with right now. So we do the webinar, we do this series, which is always the second Wednesday of the month. We run the conference. This year will be in Austin, Texas, September 25th to 27th, and that includes tutorials and various kinds of presentations. And we also support the website through various written materials and so forth. So if you have an urge to promote something about your work, we are happy to do a guest blog post. So do get in touch with us if you're interested. And finally, our workforce development area provides various kinds of opportunities for students and faculty, primarily to help build the community of gateway developers and the pipeline of those people moving into that community. So as part of that, there are summer workshops and also workshops at conferences, as well as an internship program. And I'll mention in particular that the internship program is always looking for gateways for students to work on. So we do have on our website in the workforce development section, which is linked from, I'll put up a slide at the very end of this, but essentially the student opportunities section has a link for you to volunteer your organization as a site for interns to work on. So the last little bit I'm going to mention is a quick favor at the end of this webinar. If you could give us some feedback. Essentially, we get our money because the NSF wants to see that we are doing good stuff. And if you can give us your feedback, which will take 30 seconds or less, we can help demonstrate that we're offering something of value. So we'll be putting the link to that feedback on our chat channel as well. So with that, I'm going to hand this off to our presenters today, who I'm very excited to introduce. So we have 2 folks from Google, and they're going to share their screen in a moment. They are going to be talking about the Google Cloud Platform, and the 2 folks who are presenting are Karan, Bhatia and Alicia Salmeron. And there they are waving hello. They're very friendly, and they will be teaching you how you can also submit your questions through their chat system, which is, of course, a Google chat system.
Thank you,
so
Catherine.
Take it away. Yeah.
Thank you, and thank you to SGCI for having us today. My name is Alicia Salmeron, and I am a program manager on our Google Cloud Higher Education and Research team.
And my name is Karan. Bhatia. This was really to work with the science community and help to help that community leverage cloud where we can.
For today's webinar, there's so much that we can cover, but we're going to start with an overview of GCP, provide some use cases, and there we go. And then also discuss in detail some of the programs we offer specifically for the academic computing audience. Let's make sure we're set. As Catherine mentioned earlier, let me make sure that this is hidden. We are going to have a new way of showing questions or of doing Q&A. And I just want to there we go. Just needed to get that set up. So as you'll see at the top, there is a banner that says ask a question. If you go to the short link, you can submit any question that you have, as well as upvote or downvote other questions. And this will enable us to prioritize questions at the very end of the webinar. If you would rather continue to just put questions in the chat box, feel free to. We'll make sure we look at those as well.
And I just want to make sure you guys can see our screen and you can see the title slide.
Yep, we can see it.
Great.
Fantastic. So you all most likely know Google as a consumer company, and that's true. That's what we've been doing for the past 18 years, to organize the world's information and to make it universally accessible and useful. And as you see here on the slide, these are 7 products that now all have over 1 billion users. But what's significant about the fact that these are global products is the infrastructure behind them. It's Google's core technology infrastructure that we had to build in order to achieve our mission. So for search, we very early had to build the machine learning and the AI foundation that returns contextually relevant answers and understanding patterns and user behavior to provide top results. For Chrome, we need the foundation for secure devices. For YouTube, the infrastructure to support video, and on for each product. But all of these together, we've had to build this end-to-end secure and scalable infrastructure. And for the first time, we now want to make it available to our customers. But when I say Google, this is probably what comes to mind. It's a simple short search box. But when we look at that screen, we really don't just see a search box. We see all the infrastructure that make those wonderfully simple experiences possible. And a fun fact that I actually learned just the other day is that when you type in a single Google query, it takes more compute power than all of the Apollo missions combined. And it's only by investing in this infrastructure that we've been able to make our products possible. So imagine it's 1998 and you're indexing the entire World Wide Web. What kind of database is up to this challenge? Indexing the web does require storing multiple copies of the entire web. And what file system is able to support that? So as our user base grew, we had to figure out how to manage computers at incredible scale. And solving those challenges is required to build the world's best infrastructure. And when we say infrastructure, you probably think servers, and that's absolutely part of the equation, but infrastructure does mean hardware, but it also means the software, the network, the operations. All of those, as you know, are required to build and operate at scale. And now for the first time, Google Cloud Platform, which we'll also reference as GCP, is our 8th business serving over 1 billion end users. And I'm going to assume that most of you on this webinar have at least been exposed to other public cloud vendors. And so we're kind of surpassing some of the basics, but we do really want to focus on what makes Google Cloud Platform, or GCP, different from your other options. And what we start with is our global network and security. This slide might be familiar from other cloud presentations you've seen, and really what it's showing is that our services are available in locations across the world: North America, South America, Europe, Asia, and Australia. And our locations are divided into regions and zones. You can choose where you locate your applications to meet whatever latency or availability and durability requirements that you have. And what I'll note is that just a year ago, when we started off 2017, we had 5 data center regions as part of our public offering for Google Cloud Platform. And in just last year, we added 8 regions to support the infrastructure. And in the coming year, we're going to be adding an additional 5 for a total of 18 regions. And what's significant is how quickly we're able to do this. And it's because of the major investments that we've been making for years. We do operate one of the largest backbone networks in the entire world, connecting our data centers with hundreds of thousands of miles of fiber optic cable. And there have been multiple third parties that estimate that more than 25% of global internet traffic flows over our network in a given day. We have more than 100 points of presence across 33 countries, and we're continuing to add and scale zones and regions to meet the needs of our customers. Our network delivers low latency, but it also improves security. And we understand that this is incredibly important to our academic and scientific research customer base. I already talked about most of these global network. Continue on to security. And the topic of security is something that we could absolutely talk at great length and go into great detail. And if that's something of interest to you, we do encourage you to reach out for us to go in depth. But at a high level, our approach to security is layered defense in depth. And it's layered because you need to invest everywhere. You need to invest in every layer, from the lowest level hardware, such as the Titan chips that I'll get to in a moment, through to the storage and the network, and then the way that developers are using and interacting. This starts with the size of our investment. So we have over 700 security professionals working on GCP, and I'm not including the guards of our data centers in that number. These are high-level researchers, security researchers that are looking for hidden vulnerabilities, running penetration tests, and just constantly reviewing design and architecture documents for new services. And a fantastic example is just last weekend or week, we all heard about the security vulnerability affected by practically all organizations. And you may have noted that it was a Google engineer from our Project Zero team that identified that. A similar example was with Heartbleed. This was a pretty serious vulnerability in OpenSSL that in some cases allowed hackers to steal private keys and other information. That again was a Google security researcher that discovered that, and it was Google systems that were able to be patched prior to any public disclosure, similar to the most recent event this past week. We provide, and it's the level of security that you really should expect from your cloud provider. This is an image of our Titan chip. Titan is a Google-designed crypto processor established to establish hardware root of trust. So we insert these into every piece of hardware that moves between our facilities. And the picture you see is a network card, and the little blue dot is Titan. Titan's let us ensure that nobody has been able to modify any of our systems, starting at the very lowest level. And again, to know that nothing has been tampered with, we must think about protecting data. And at GCP, we use encryption by default, both in transit and at rest. We require all connections to GCP to be encrypted. From there, we encrypt all the data automatically. First, data is broken up into chunks, and then each chunk gets its own individual key. And those keys themselves are encrypted, and the chunks and encrypted keys are spread across the storage infrastructure. So that even if an individual key was somehow stolen, it wouldn't be enough to actually access the data. And even if in some physical media were stolen, the individual, the hacker, wouldn't be able to reassemble the original file. These are some of the third-party certifications that we do have for GCP, and we're constantly adding additional ones. What may be applicable to this audience is HIPAA and FERPA. We do have a business associates agreement, or BAA, that we can sign with your institution, and we also have FERPA compliant services. And again, we're happy to go in further detail on these topics individually. The next component that we differentiate ourselves with is compute and data analytics. And for that, I'm going to pass it over to Karan.
Hi, guys. There's a whole suite of tools and capabilities that are available in GCP, and so we've only taken a few parts of that to talk about today. So I just want to reiterate that this is really kind of a high level intro to GCP, and we're very interested in providing deeper trainings or deeper brief on various parts of GCP that are going to be most relevant for the Science Gateways community. So that's feedback that you could provide to the Science Gateways community, and we'll work with them to identify what those topics are and provide deeper dives. But for today, we thought we'd talk about compute and data analytics, mostly on the compute side, and then talk about some of the kind of the dev tools as well, since you guys are, my understanding, building these science gateways for your communities. And then we'll talk about some specific programs that we have on the EDU side. But let's start off with compute. So as Alicia mentioned, that this infrastructure we've been building we've been building it for 18 years. So it is global. It is custom. We design all of our servers. All of our racks. There's no component within our infrastructure that isn't used. We have security components within that. Make sure that even our providers are not. There's no capability of modifying any of the code that we get. So the other aspects of it are really fast startup times. For large-scale compute systems, for example, if you were to run a Slurm cluster, you can actually burst or scale a Slurm cluster very, very fast. So you can add, for example, if all of a sudden there's a whole ton of jobs, you can add more nodes to that Slurm cluster. And this last week we were doing some tests with that, and we were able to nodes in under 5 minutes. So that's not the provisioning time, but that's provisioning time plus plus all the time it takes for configuring Slurm and getting that integrated into the cluster. So you can scale up, you can scale down, and you can do it very fast. One of the key capabilities that we have is called live migration. So as Alicia mentioned, in terms of these security vulnerabilities, we were able to patch all of our systems, and we were able to live migrate our customers' instances from one physical server to another without any downtime for the application. So that means what that means for users is higher reliability and fewer instances where you have to, go in servers, or once you have your systems up and running, you're gonna find that they're going to be very stable and run for a long time. Another aspect of our infrastructure is in how we do the pricing. So we try for simplicity, right? Once you move to the cloud, sometimes there's a lot of complexity in managing your cloud installations. And so we want that to be as simple and as efficient as possible. So for example, the longer you use a VM, you automatically get long-term use discounts. So that means that as you use it more, your hourly price, your on-demand price is actually going to go down. We have the capability for preemptable VMs, which are VMs that you can use, but you may be taken away from you without much notice, and we give that to you at an 80% cost reduction, and you don't have to. And it works just like any other VM in terms of provisioning. It's just an extra flag. You don't have to worry about dealing with the other cloud vendors have auctions, and there's a lot of complexity to managing that. And the Google Cloud infrastructure is much simpler in that sense. We also work very closely with Intel, and as new processor architectures come online, we are really the place where you can get access to them first. So, for example, the Skylake processors were announced last February, and we were the only place where you could get Skylake processors for a good 6 months or so. And even today, we offer 96 core, very Skylake processors for our customers. So they're very performant. As new technology comes to market, we're going to be providing that and providing access to that to our customers. And it's not just the processor, but also the GPUs. We have a great relationship with NVIDIA. We offer the K80s and the P100s, and so even if you look at the GPUs, right, you're going to be getting a variety of GPU offerings, which are going to be relevant for whatever application that you guys are running. And in addition to providing those, we've also developed our own accelerators that are like GPUs. We call them tensor processing units, or TPUs, and those are that are focused on machine learning applications. So both the training as well as the prediction part of it. So you can do, as you scale out your machine learning applications, using the TPUs is going to be more cost effective and scalable to run on GCP than any other infrastructure. So we have a lot of users that are making use of this compute capability at a very high scale. And we have one researcher at MIT, for example. He did 580,000 cores using preemptable VMs. So he was able to do his number theory in a way. What he was looking for certain types of curves within a 15-dimensional space, and it was a very kind of compute-heavy workload. And he had access to traditional HPC clusters on campus and at national centers, but he chose to use GCP because it provided a very cost-effective and very scalable solution, and he was able to run this over the course of a weekend in order to get the data that he needed for his analysis. So the scale that you can achieve is pretty tremendous. Now, what he did was he built everything himself, right? So he used a cloud data store for storing the job metadata and the task status. He used his own service that he developed running on Compute Engine to do the provisioning of nodes. In his case, every node that he provisioned was one particular job that he needed to run. And with per second billing, that's really fairly cost effective, right? You would think that you want to spin up these servers, and because of the traditional overhead of the time it takes to spin up servers and to make use of them, you would think that maybe you need to run them for a long time and reuse them for many jobs. But with per minute billing and a really fast provisioning time, it really you didn't need to. So he was able to, one provisioned VM was equal to one job. That simplified his scheduling, and so he was able to very simply write a scheduler and then put the data, both the metadata in Cloud Data Store, as well as the output data that he needed in GCS and Google Cloud Storage. So in this case, he didn't use existing infrastructure, but we have been working with as another example, we've been working with the Broad Institute on their computing infrastructure. So they're the largest the largest genome sequencing center in the United States, and they do a tremendous amount of high throughput computing. What they really want is a framework, is a platform for doing really a variety of different types of analytic pipelines. And so they built their platform on top of Google Cloud Platform, and were able to develop a workflow description language as well as an execution engine. The workflow description language is called open source. Cromwell is their execution engine, and the execution engine actually sits on a product that we have called the Google Genomics Pipelines API. Now, the Pipelines API is a serverless, high throughput application. So you give it a set of tasks leveraging containers, and it will do the provisioning, the scheduling, and the execution of those tasks and get you the results back in a GCS bucket. You don't have to spin up a cluster. You don't have to really do any of the provisioning. So if you want a simple framework for executing a large number of tasks, this is a very easy one. And I'll just show you some examples. Here's a pipeline definition. This is one using this is a pipeline that runs SAMtools, which is a genome application. Excuse me. And you can see that really the at the bottom there, you see the Docker properties. You can see that they've developed a Docker container that has their tools, as well as a command that they want to execute within that Docker container. And then you can parameterize certain aspects, maybe the data file or other variables, and you can run this, many times through the command line or through other ways. So here's an example of creating the pipeline just through using the command line tools, and then executing that pipeline with a particular set of input and output files that are specified on the command line for that. So there's an even simpler way, which is an open source project called dsub, and this isn't an official Google product, but it leverages the Google Pipelines API on the back end, and it simplifies the execution of high throughput tasks that you could just define on the command line. So you can build your own system for managing high throughput computing. You can use Google Genomics Pipelines API to manage the provisioning of the nodes and use containers for your application. But we also have been working with the kind of standard community tools that people know and are used to. For example, Condor and Slurm. So we've been working with Fermilab, for example, on some of their analytics. So in particular, their HEP cloud, and we were able to. They have a tremendous number. They have about 100,000 cores on premise, but still they need more. And we were able to burst using their existing Condor infrastructure, burst into GCP to the tune of about 160,000 cores. So this is.
Just noticed the Q&A went off, so let's just reset it to make sure it's on.
Uh-oh.
Just go back to present and redo it, I think. No? Yeah. Never start new.
It's not letting me
Just start a new one, I guess.
Okay.
But I saw the question that was in there earlier.
Okay.
Huh. I'm sorry about that. I don't know what happened. It's okay.
We can also let you know about questions coming through our Blue Jeans chat too, just so you know.
Okay.
Absolutely.
Okay. Keep going.
So the Fermilab analysis in terms of the cost for compute showed that the overall cloud, I think the upshot here is that the cloud costs in their analysis was a little larger. In our analysis, it was a little less, but in their analysis, cloud was a little larger, but the costs were approaching equivalence. This capability is the capability to burst was really a critical capability for the HEP cloud. I'm going to kind of go through this a little bit faster. And
can I just wanted to interrupt briefly. Someone said that there's a permission issue with the new Q&A.
Yeah, we didn't let people outside of our domain. Sorry, we are trying to do something different to improve the process, but clearly we don't have. we are experimenting, so bear with us as we encourage. I just love this model because it encourages people to ask questions anonymously, as well as show their preference for other questions, just so we see where everyone's at. All right, so hopefully now everybody can ask questions, not just Googlers. We're all about security here. And we should be set.
So we've also been working with SCAD-MD and Slurm. So Slurm has two capabilities with GCP. One is you can very easily deploy a Slurm cluster using a tool called Deployment Manager, which you can create a multi-node system using Deployment Manager, and you can, using the scripts that SCAD-MD has developed, you can create a Slurm cluster. One of the things that it has built in is the ability to scale based on queue depth. So as the number of jobs in your queues gets larger, you can define a policy where you add additional nodes in order to deal with that. So for example, you can start off with 2 nodes, which is very small cluster, and you can, as more jobs get added to the queue, you can scale that up. And scaling is very fast, and you can scale down as well, and you can define a time. For example, you could say if in 30 seconds the node don't get any jobs, you can free those nodes up and scale back down. So you have a lot of the capability. Another new capability with Slurm and GCP is federation capabilities, and that is that you can have multiple different Slurm clusters on premise and in the cloud, and as you submit jobs, you can decide where to route those jobs, and if appropriate, you can route those jobs up into the GCP cluster or an on-premise cluster, depending on what it needs. So, for example, if it needs particular GPUs, then you could have a cluster in GCP that has those GPUs available for them. If it requires InfiniBand networks and things like that, then you can route those into on-premise. So I'm going to just briefly talk about storage, and there's a variety of tools around storage that Google provides. At the one end is object storage, right? So this is pay for what you use, very scalable. If you have petabytes of data that you want to store, Google Cloud Storage is very cost effective. It's very performant. You can access it in parallel, and it's an object storage system. And then we have a variety of other both non-relational as well as relational and data warehousing tools, all the way up through, say, BigQuery, that provides a SQL engine as well as data storage for that. We have a block storage as well. So we have local SSD, we have persistent SSD, we have spinning disk, and the cost for these and the performance of the various services here differ. And so depending on your application, you can really customize the infrastructure to be what you need. And as that changes, or as other capabilities come online, you can evolve that. So instead of having an application which is being adapted to the infrastructure, you have the infrastructure which is adapting to your applications. Talk about a couple other tools within the data side. A new one is called data prep. Data prep is really, most data scientists or folks that are working with the scientific community, they end up doing a lot of data wrangling. That is, they take their data set, they need to be able to process it. They first need to look at it and clean it. They need to split certain columns. And so data prep is a tool that is really designed for that. And so you can look at your data, you look at the distribution of values, it automatically determines the various data types. It shows you what the distribution of values are, and it allows you to find things which are maybe have undefined values, so you delete them, and you create a set of recipes, right, that for processing that can be repeated. So you can do this on a small data file, or however big it is, but you can once you define the set of transformations on this data file, you can save those transformations and rerun them again and again and again on other data sets, and do it in a batch mode. So the other set of tools that we have really are around not just data storage or preparation, but it's really a full suite of data tools to transform your data essentially into actions. So you have to store the data, process the data, maybe ingest the data from mobile devices or other places. You have to do data science. So we have a cloud data lab, which is a managed Jupyter notebooks. We have BigQuery for doing SQL data warehousing applications. We have DataProc for Hadoop clusters and Spark, and all the way through to things like machine learning. Right? We have built-in models that you can leverage, like the Vision API and the Speech API, and then we have more generic machine learning tools like Cloud ML that allow you to define your own models, bring your own data, and develop your own applications around machine learning. So the other aspect that I wanted to talk a little bit about is Kubernetes and development tools. So you're probably familiar with containers. You're probably familiar or heard the term of microservices. So what Kubernetes is a container orchestration system. So it's great to have a bunch of containers. You can containerize your applications, and that way that the containerized applications don't all have, you can separate their dependencies and develop in a much easier way. But in operating these containers, right, that's a challenge. So container orchestration means you want to have a cluster of nodes. You want to be able to define which containers, how many of those containers you're running. You want to be able to scale them, and you need to manage the interdependencies between them in this kind of microservice architecture. I guess one question that people ask with respect to the Kubernetes logo is, why does the logo have 7 handles? And the reason for that is a Star Trek character named Seven of Nine, who was from the Borg. So maybe in the weeds here, but the Borg was this group that and Seven of Nine kind of escaped from the Borg, and she served in the Federation, but she was it's the reason Borg is brought up is because Borg is our internal container management system, right? So we've been doing containers here at Google since really the start of containerization. We launch, I believe it's something like 2 billion containers every day. We manage all of our infrastructure is containerized. So that means that Gmail and YouTube and search and all those applications running on our worldwide systems are all containerized, and Borg is the system that manages that. So what we've done with Kubernetes is really taken our internal system and our lessons learned and developed an open source framework for container management that does really much of the same things that our internal systems do. So it's been getting a lot of traction, not just in the cloud, but also on premise. It's an open source project. You can run containers on premise. You can take Kubernetes and run it really anywhere. And there's some really interesting capabilities that are being built into Kubernetes for scientific computing. And I'll just mention one of the capabilities that people are developing and beginning to leverage is cluster federation. So again, when we talked about the federating HPC clusters from on-premise to cloud, we see that also with Kubernetes and containers. So you could have on-premise Kubernetes cluster and a cluster in cloud, and be able to federate them and leverage them together and have declarative rules for moving instances back and forth. You can also do multi-cloud, and you can also do clouds or clusters in multiple different regions. So for example, if you had an East Coast and West Coast cluster, you could start off in the morning having more resources in the East Coast cluster and slowly migrate as the day moves on into West Coast. So you're really able to manage these multiple clusters as a single cluster in a scalable way. So we offer Kubernetes. We offer a service called GKE, the Google Container Engine. We just spell container with a K, so make that distinction between GCE, which is the Google Compute Engine. And what that allows you to do is essentially, running Kubernetes is there's a lot of complexity there, and GKE, Google Container Engine, is a managed Kubernetes service. It's the same open source Kubernetes that you're used to. It's compatible, and it just makes it a lot easier to run. You pay for the compute, you pay for the data, and so it's very cost effective as well. We're going to switch gears a little bit and talk just briefly about some of the EDU programs that we have available.
And thank you for all the questions that are coming in. I do want to say that we're going to try to get to all of them, but if you want to go ahead and vote for some over others, that'll just help us prioritize. So these are the three areas that my team that focuses on higher education thinks about as we think about GCP: administration or central IT, research, and then of course teaching and learning. Oh, I lost my place. So we do have a GCP education grant program that we offer specifically for teaching and learning environments. So it is free GCP credits or coupons. I believe it's $50 per student. Of course, depending on the specific course use case, we will work with you. And it originally was focused only for computer science, but we are absolutely expanding that to cover the interdisciplinary use cases within data science that covers all fields of study. We just came from a workshop yesterday that the NSF hosted, in which we learned about some of the great work happening with the Data Science 8 program at UC Berkeley, and we want to continue to work with you or with the education community to see how can we enable courses and programs across different institutions to share what they're doing and have cloud be a part of that catalyst. So the site is on the slide, cloud.google.com/edu, and any professor can go ahead and apply for grants on that site. And this is kind of related to that, but really it's for anybody. We do have GCP fundamentals trainings. These are really fantastic full-day trainings to get you familiarized with our core infrastructure all throughout the country. And if you'll look here, we will definitely share this information out afterwards. But there are 2 trainings as well in February in San Francisco and Chicago that are focused specifically on the big data and machine learning. You do not need to attend the core infrastructure course in order to attend the machine learning one. And you can go ahead and contact the team at Science Gateways or myself. My email is on the slide. And again, this will be shared if you would like to be registered. These are free, but they do require a private invitation that we can send to you or your staff if you're interested. And the location is our Google offices within each of these cities. Oh, did we skip some slides? Oh. Okay, somehow some of my slides disappeared. So I'm going to go back to this slide and touch on administration. So we do work with Central IT across all campuses to discuss some of the very common use cases, whether that's storage or lift and shift migrations. And the area that I focus on specifically, though, has been within research. We have found great synergies partnering with the advanced research computing departments, as well as individual researchers. Some common use cases, and these have been referenced by Karan, have been complementing existing HPC environments through bursting to the cloud or GCP, enabling you to sort of prioritize what type of workloads you want to use for your environment, but maybe think about the types of batch computing that would be better suited for the cloud and could improve the researchers' experience in either accessing resources and being able to ask either more questions or just time to insight is reduced. The bioinformatics area, as referenced by the genomics API, has been incredibly popular with GCP, just based on the extremely low cost we're able to provide compute. We have something called preemptable machines, and I don't think they've come up yet in our presentation, but preemptable machines are VMs that can be preempted, right? So if you are familiar with Amazon, I think that those are considered spot instances, but the big difference with preemptable machines on GCP is that they're at a fixed price, right? So no matter what time of day it is, you get 80% off the list price because of that possibility that the machine will be stopped, but it is all done in a smart way. So, machines are only preempted. The one that's been running the least amount of time is preempted so that jobs do finish in a faster fashion. But this is incredibly popular amongst the research computing, the researchers using just basic batch compute. Another area that we've really seen a lot of interest amongst the research community is within the machine learning area. Not just the ability to create your own algorithms using our machine learning engine, but also the ML APIs that we offer out of the box. There's the cloud API, speech, translation, natural language processing, and video. And these are all fantastic tools for the research community. And, I could go on, but I just wanted to sort of paint some pictures of ways that we are partnering with campuses and would like to work with you as well. So with that, we are going to transition over to some of the questions that we have. And Karan and I will kind of go back and forth. The first question that comes up is regarding data transfers and what Globus has. And before I transition it over to Karan, I do want to say that we are interested in working with Globus, and I do believe that they already have the service of getting data into Google Drive, but it's not currently automated for GCP. If that is something you're interested in, we would love it if you would communicate that to the Globus team. GCP storage on GCP is different than file storage on Drive, and they shouldn't be confused. So that's definitely something that we encourage you to express interest in.
And we do have a product called data transfer service that allows you to transfer in an automated fashion data from on-premise into GCS. And the other thing I would say is that if you take a look at just the basic tools like GSUtils, while it's a command line tool for moving data, it actually supports a lot of the kind of the advanced capabilities, including parallel data transfers. So you can very easily use that to if you have a SAN a large scale data system that you're transferring data from, then you can definitely do that in parallel, and you can do that across nodes as well fairly easily. So take a look at those, and then we would definitely have been in contact with the Globus folks, and so as you guys express interest in GCP as an endpoint for a Globus transfer, I think that would be great.
And the next question regarding some of the tools we can share with research computing. So I don't know if the intention is sort of collaboration, not in, well, anyway, so some of the resources that we do provide that I think research computing centers are very interested in is around some of the latest in GPUs, TPUs. We are often able to get those to your users much more quickly. And if that's of value, that's absolutely an area that we can support.
Yeah, and tools like Kubernetes and TensorFlow, those are all open source tools that we have put into the open source community, and we have plenty of people who are using those on premise and everywhere else. So we recognize that hybrid computing is definitely something that many people are doing, and so we want to make that as easy as possible. Can I point to documentation for creating a Slurm cluster in GCP? Yes. If you search for
we'll send out.
Okay.
We'll follow up with links.
Okay, yeah, we'll follow up with specific links. But if you do a Google search on cluster computing on GCP, you should find a document that kind of lists the various options, as well as a detailed tutorial on using Slurm. There are a couple ways of doing Slurm. One is with Elasticluster. Elasticluster is open source software from University of Zurich. It does support other schedulers as well. It does support PBS. It supports Grid Engine as well as Slurm. We have a number of users that are using that open source software for creating the Slurm clusters. In addition, our partnership with SCADMD, we're developing, like a native deployment manager scripts for launching Slurm clusters, and that should be available pretty soon. But we'll send out some of the links. Does Kubernetes support other container formats other than Docker, and in particular Singularity? No, it only supports Docker. Singularity was really defined. It was really created for a particular environment where running containers in traditional HPC systems was difficult. In Kubernetes, you don't really, or in your own cluster running Kubernetes, you don't really have that problem. So you can run Kubernetes clusters, you can get access to GPUs, you can do all of that. So I'm not sure that Singularity is solving a problem that you have in Kubernetes clusters, but that's just my feeling. But as of now, no, we don't support other container formats. Yes, we can make the slides available.
Just add that I put a link on in our chat section to our archive, just so you know that's where we put our recording. Yeah.
Okay. And another question is, do you have programs similar to the EDU program from small science gateways at academic institutions that are not involved in teaching? So we do have a partnership with the National Science Foundation. We are working with them through a couple of programs that they have. Last year was the Big Data program. So you write a.
Oh no, what happened?
My session got closed.
I wonder if there's a timer on it and we don't know about it. I have a screenshot somewhere about some of the questions, but
apologies for
our questions just disappeared on us, so we think that maybe there's a timer we don't know about. But regarding
we could have people email you questions too, right, Alicia?
Right. Yeah, we're coming up on time, but I just wanted to make sure we finished up on, are there EDU programs for science gateways? And we are working with NSF to see how can we better enable the research community and maybe specifically this community to evaluate and explore with the cloud. I think yes, we're absolutely willing to partner with you and, communicate with us. What is it that you want to do and how can we support you? And then two, I think it's important for your programs or your funders to know that this is something you want to explore as well, because that's not always necessarily obvious.
Right. So, and then the last question just to address is, are there existing collaboration efforts with research computing centers or more competition than collaboration? Absolutely, we think of this as a collaboration. The traditional HPC and the supercomputing centers have different types of machines, really low latency, really fast parallel computing. So we think that we're working with many of the HPC centers on campus as well as national scale to find ways of combining, right? It's not just about parallel computing. You do parallel computing, you still need data archives, you still need data storage and data analysis tools. So we think that partnering with the HPC centers is definitely what we're not trying to compete with them. We're trying to complement some of the capabilities that they have for their users. Does Google provide?
Well, Catherine, we have 2 more questions. Are we allowed to answer them, or I know it's top of the hour,
sure.
so people.
People tend to just leave when they're ready, so you can go a little extra. Yeah.
Okay. Does Google provide something like Amazon's Lambda function service? Yes, it's called Google Cloud Functions, and it is. Do a Google search on that. That is publicly available. Do you support PBS Torque instead of Slurm? Yes. So we have a partnership with Altair, and if you look at what they're doing with PBS Cloud, that will support GCP, but also Elastic Cluster, the open source software from University of Zurich, supports Slurm as well as PBS Torque.
And if you have any other questions now or at any time, please do not hesitate to reach out to us. And please let Catherine and her team know, what specifically within Google Cloud do you want to learn more about, and what would be useful to you. We didn't do any demos today. We just really wanted to provide a very high-level introduction. And so we hope that this is just the beginning of some deeper conversations. So thank you for attending.
And thank you, Alicia and Karan, for presenting today, and with a packed bunch of information. I can tell that when you have a lot of questions being asked, that that people are really engaged and wanting to learn from you. So we will continue the conversation and find out if future topics that we could feature would be some demos or other informational presentations.
Great.
So to all of you, thank you for joining us.